seen it already on e-learning. Test 3 will be on the 6th of July. So this test 3 will cover the topics of equations and inequalities, sequences and series, and the last topic, which is trigonometry. Okay, so where we left off with the equations and inequalities, that is where the next test will begin. And then sequences and series, this is a pretty short topic, not very difficult. And then trigonometry is also not a very long chapter, so we shouldn't take too long. So remember, the assignment is due on Monday. So do not wait until the last minute to submit it. So if you're done, go ahead and submit. I've seen some people have submitted already. That is good. If you wait for Monday and e-learning crashes on that day, that is not an excuse. You have had more than a month, well, not more than a month, almost a month to do it. There should really be no excuse for you not to submit it on time. Okay, then the supplementary test. This will be on the 8th of July. So you can see test 3 is on the 6th, then 2 days later we have the supplementary test. Now notice the supplementary test is not for everybody. This is for students who have missed a test. So if you missed either one of the tests, you didn't submit on time, you qualify to write the supplementary test. And this is also for students that have a grade that is less than 50% overall. Okay, so you calculate the average of your tests. The average of your tests should be about 70% of your grade. This will come from the 3 tests, and then about 15% each from the tutorial tests and the assignment. If when you calculate that it is less than 50%, that means you have not passed the course, then you qualify to write the supplementary test. Otherwise, you do not write it. And then students that write the supplementary test because they fall into this category over here will only be able to get 50% if they pass the test. So that means even if you get 100% in your supplementary, and when I work out the average in the normal way, it comes up to 60 something, your final mark will be 50%. Okay, so supplementary is not for improving marks. Nobody can improve their marks. You get one chance, you don't, the supplementary is 50% or it's a fail. Okay, so you will not get 51 or above 50, nothing like that. You will not improve your marks if you fall into this category. If you have missed a test, that is not the same thing. Okay, if you have missed a test, then the supplementary will take the place of the test that you have missed. If you have written all your tests, but your grade is still less than 50%, then the supplementary can help you get to 50% only if you pass, and you need to pass with a certain amount depending on what your grades are. Okay, so I hope that is clear. It is all on e-learning. Tutorial test 10 is on e-learning. It will start at 10 a.m. Please read the instructions before you start. I'm getting a lot of people sending me messages, Miss, I want to claim my marks. Why is this marked wrong? but they have not read the instructions. It is very important for you to follow instructions. If you read your course outline, you will see that one of the graduate attributes that we try to instill in you is the ability to follow instructions. And this is not like very complicated instructions. They're pretty simple that anybody should be able to follow. Okay? So if I say, do not leave a space, that's not difficult to do. Or if it says leave it to 3 decimal places, that is what you should do. Okay, the system is very rigid. It is meant to test, are you able to follow instructions? Because any minor deviation from the way it wants it is wrong. So we are trying to instill in you that ability to follow instructions. So please follow instructions. Don't tell me that the answer is 5, and then you wrote x is equal to 5, and then you ask me, why am I getting it wrong? When in the instructions, it clearly tells you this will be marked wrong, and then you decide to write it. I know it'll be marked wrong, but I'm just going to write it. No, you will not get any marks for that. So please, before you email me and tell me that this is correct, x is equal to 5, yes, it is, but your inability to follow instructions will make you fail. So before you start, read the instructions. If you're trying to save your data, somebody told me that they don't have data to read the instructions. I thought, then you're just going to fail. You're wasting your data in the end. Maybe ask somebody to screenshot you the instructions, then you can read them ahead of time. Make sure you know the instructions. And this week with inequalities where our solutions are in interval notation, it is extremely important that you write it the way I have said that you should write it. Any minor deviation from that, it will be wrong, and I will not give you a mark for writing it incorrectly. Okay, yeah. Do we have any questions? Something to say? Anybody? Or are we fine?
Ma'am?
Yes.
Ma'am,
Yes.
how many tutorial tests will be chosen to cover assignment 1?
What does it say in the course outline? Doesn't it say all your tutorial tests?
Oh.
I believe it says that every single one of your tutorial tests is important. Because I know the moment I say 9 of them, some students will say, oh, I did okay in all my, then they don't do the rest. All your tutorial tests are going to count for your marks.
Okay, ma'am.
All right. Okay, so let us finish off on this chapter. And then tomorrow we should be able to start on the next one. So please keep those dates in mind. Very important. Next week, Monday, the assignment 2 closes. It closes 4 o'clock. Make sure you have submitted on time. Make sure your graphs are drawn on graph paper. Make sure it is handwritten. Follow all the instructions because you will be graded on all of those. Okay, and then 6th of July is test 3. 8th of July, just 2 days later. We may even move it so that it's the day after, but supplementary test will cover the entire syllabus. So from set theory up until trigonometry, that is what will be in the supplementary test. So as much as possible, do not leave it so that you have to write the supplementary test because it is a big test. It covers a lot of things, unlike test 1, 2, and 3. Passing those is much easier than to pass the supplementary test. So do not think, okay, no, I'll wait for the supplementary. Don't do that. Okay, but anyway, I thought Saturday's test was okay. People were complaining that e-learning is slow. I tried to increase the time. Still I got emails yesterday, 24 hours after the test has closed. Miss, here is my test. So can people tell me what must I do with such people? 24 hours later, somebody is submitting their test. So this person has had a massive advantage over the entire class. And I'm sure if I were to look at this person's paper, straight 100%, a perfect memo. Okay, so please, I know it is difficult. It is also challenging for me. Okay, and I understand you don't have data or whatever is happening. Okay, I understand. But please let us try our best. I also would prefer that we have face-to-face classes. We write in the basement, we are done. But we cannot do that. So let us just try and work together until all of this is resolved. Okay, so our quadratic inequalities. So we looked at some examples yesterday, not yesterday, in the last class. We said that if you are given a quadratic inequality, first thing you have to do is factorize it, find your critical points. The critical points will tell you how to divide your number line, and then you form a table from the number line. And then after that, what you do is you will pick the region that represents what it is you are looking for. So if we look at an example, this is x minus 2, x plus 5. This is less than 0. Okay, now this one is already factorized, so we don't need to factorize it. From here, we just go ahead and find the critical points. Now to find the critical points, we equate each of the factors to 0. This means that x is equal to 2, and then x plus 5 is equal to 0, which means that x is equal to minus 5. Okay, so those are your critical points. Then what you do is you draw a number line with your critical points. So this is your number line. You have 2 here, and then you have minus 5 over there. So you can see my critical points have divided my number line into 3 parts. Then I form a table from the number line. Then my 2 factors, I will put them in the table. So I have x minus 2, and then I have x plus 5. Then we said what you need to do is you pick a representative into each of the regions that the critical points have divided your number line into. So we have this first quadrant over here, the second, not quadrant, first region, second region, and the third region. So I had one number line, then when I put the number 5, the numbers negative 5 and 2, my number line was divided into 3 specific regions. And now what I do is I pick a representative from each of those regions. Now the number that you pick doesn't matter as long as it is in that region, and it must not be the boundary points, because at the boundary points you'll get 0. Okay, so we can pick a number less than negative 5, let's say negative 10. Then a number between negative 5 and 2, let's say 0. And then a number greater than 2, let's say 10. So again, the number you pick doesn't matter as long as it is in that region. Okay, so people that pick different numbers, they will get the same result, because what we're interested in is not the value that you get after you substitute, but the sign of your value. All right, so if I substitute negative 10 into the first one, x minus 3, I get negative 12. That is negative 10 plus 5. This is negative 0 minus 2. That is negative 0 plus 5. This is positive 10 minus 2, positive 10 plus 5, positive. Okay, then in the last row, I write the product of the 2 factors. So I have x minus 2, x plus 5. and then I multiply, because this is the sign of the first factor, that is the sign of the second factor. In the last row, they are multiplying, so I also need to multiply their signs. So negative times negative, this gives me a positive. Negative times positive, this gives me a negative. And positive times positive, this gives me a positive. Okay, then I rewrite the question after it was factorized. It was x minus 2, x plus 5. This is less than 0. So what I'm looking for is less than 0. So I'm going to the row on my table which has the product, and that row is this one over here. So this is the row. So you know how to read a table. On the left, you look at the column, then to find out what its value is, you go into rows. In the first column, this is positive. We want less than 0, so that's not what we want. Then in the second row, it is negative. Yes, that is what we want, because negative means less than 0. In the last column, this is positive, which is not what we want. So the only solution will come from this region over here. So numbers between negative 5 and positive 2. So our solution, this is numbers from negative 5 to positive 2. And these are not included because of my sign over here. There is no less than or equal to, or the equal to sign is not included. So negative 5 and 2 are not included. And I can also represent this on my number line. I have negative 5 here, I have 2 here. An open circle means it is not included. And then another open circle over there means that is not included. So that is how I would represent this on a number line. So the steps to follow when answering questions involving quadratic inequalities are very simple. First, you must factorize. If it is already factorized, that part is done for you. You don't need to do it. Then you find your critical points. After you find your critical points, you divide your number line according to your critical points. Then pick a representative in each of the regions. Substitute those representatives into the factors. Then fill in your sign table. And the last step is look at your question again. Is it less than 0? If it says less than 0, it means that you are looking for the column with a negative. If it is greater than 0, you're looking for the column that is positive. And that's it. Okay, so with this one here, it is not factorized, so I'll need to factorize it. But first, I will have to rewrite it with everything on one side and 0 on the other side. So when I subtract 4 on both sides, I'll get minus 12 less than or equal to 0. And notice that the sign does not change direction when I subtract 4 on both sides. The sign only changes direction when I multiply or divide by a negative number. And then now I factorize. I look for two numbers. When I multiply them, the answer is negative 12. And when I add them, the answer is negative 1. So this is 4, negative 4, and 3. So I put my x there, negative 4, positive 3. And then I find my critical points now. So I say x minus 4 is equal to 0. This means that x is equal to 4. Then x plus 3 is equal to 0. This means that x is equal to negative 3. Then I draw my number line. I put my critical points. So here I have 4. And then here I have negative 3. And you can see my number line is divided into those three regions. Then I place my factors. So I have x minus 4, x plus 3, right? Then I pick a representative in each of the regions. Let's say -5, 0, and 10. So these are my representatives in the region. Then I substitute each of them. -5 minus 4, this is negative. -5 plus 3, that is negative. Okay, then 0 minus 4 is negative. 0 plus 3 is positive. 10 minus 4 is positive. 10 plus 3 is positive. Then the product of the two, I have x minus 4, x plus 3. Then I multiply negative times negative. This gives me a positive, negative, and positive. This gives me a negative, positive, and positive. This gives me a positive. So I write down my question again. This is x plus 3, x minus 4. This is less than or equal to 0. So I look at this part over here. Less than or equal to 0. This means I have negative. So I look in the last row. Where do I have a negative? Negative is over there. So it is the one in the middle. And when I write this in interval notation, the solution will be -3 to 4. This time I have square brackets because I have the equal to under there. So with the previous one, it was strictly less than. That's why my brackets were round. But here, because I have the equal to under the less than symbol, then I use my square brackets. Then I can also represent this on a number line. This is -3 and 4. My circles are now shaded. So square brackets means shaded circles, like that. Okay, let's look at another one. 2x squared minus 5x plus 2. This is greater than 0. So again, first thing to do, you must factorize. So you factorize this, you open your brackets, you look for two numbers. When you multiply them, the answer is 2 times 4, 2 times 2, which is 4. And when you add them, the answer is -4. So those two numbers are -4 and -1. Then you divide by the coefficient of x squared. So here you will have x minus 2, and then 2x minus 1. This is greater than 0. Okay, so it's factorized. You know how to factorize. You should be able to do that. Then after you have factorized it, you need your critical points. We have x minus 2. This is 0. This means that x is equal to 2. And then we have 2x minus 1 is equal to 0. This means that x is equal to a half. So now that you have your critical points, what you do is you draw your number line. And then this critical points, they divide your number line into 3 regions. And put the numbers in the correct order. So here I have a half. And then over there I have 2. Then your number line extends to form a table. Then you put your factors. You have x minus 2, 2x minus 1. Then pick a representative in each of the regions. Any number less than half, let's say 0. Any number between half and 2, let's say 1. And then any number greater than 2, let's say 3. Then you substitute each of them into your factors, and then you write down the sign, whether it's positive or negative. So 0 minus 2, negative. 2 times 0 minus 1, this is negative. 1 minus 2, negative. 2 times 1 minus 1 is positive, and then 3 minus 2 is positive, and then 2 times 3 minus 1 is positive. So notice I'm not interested in the value of the answer, but in just is it positive or is it negative, and that's it. Then you put your product, then you multiply the signs. You have negative and negative, this will give me positive. Negative and positive, this gives me negative. Positive and positive, this gives me positive. Then I write down my question again. So this is x minus 2, 2x minus 1. We say this is greater than 0. Then I go to my table. I'm looking in the last row because that is where the product is. Then I look at this greater than 0. Greater than 0, this means positive. So I'm looking for where I have positive in that last row. So the first column there and the last column over there have positive. So those two are my solutions. So what I do is I write the first one. This goes from minus infinity to a half. And then the other one goes from 2 to infinity. And these are both my solutions, so I make the union of the two sets. Okay, so that is how I'll write it. And then I can represent this on a number line. I have half here, I have 2 there. My circle is open, going to the left. There, my circle is open, going to the right. So both of these ways, this is the first one, this is the second one, different ways of representing your solution. The first one is an interval notation, and then the second one is a graphical representation of your solution. Okay, so that is how you would solve it. Then number 4, we have 3x squared plus 3. This is less than or equal to 5 plus 5x. Okay, so here, just like when we're solving quadratic equations, everything on one side, 0 on the other side. So I will have 3x squared. I will subtract 5x on both sides. So I have 5x, and then I will also subtract 5 on both sides. This will leave me with negative 2. It's less than or equal to 0. Then again, first thing you must do is factorize. So you look for two numbers. When you multiply them, the answer is the same as the product of 3 and negative 2, which is 6, negative 6. Then when you add them, the answer is negative 5. So those two numbers, negative 6 and positive 1, then you divide by the coefficient of x squared. This is less than or equal to 0. Then simplify as far as possible. This is x minus 2. And then we have 3x plus 1. This is less than or equal to 0. Then find our critical points. The first factor, x minus 2, is equal to 0. This means that x is equal to 2. The second factor is equal to 0. This means that x is equal to minus 1 over 3. Then, now that you have your two factors, the two factors divide the number line into 3 regions. So you place your factors. I have negative a third, and then I have 2. Then you extend your number line to form a table. Then you have x minus 2, 3x plus 1, and do that. Then you pick a representative in each of the regions. Any number less than minus 1/3, let's say minus 1. Number less than a number between negative 1/3 and 2, 0. And then a number greater than 2, let's say 3. Then you substitute each of the numbers into your factors, and what you're interested in is the sign, not the value. So I say -1 minus 2, this is -1 times 3 plus 1, that is -0 minus 2, -3 times 0 plus 1, this is positive, 3 minus 2, this is positive. Then we have 3 times 3 plus 1, this is positive. Okay, so you know how to read the table. Substitute in here, this value there, this is what you get. This value in there, this is how it is. This value in there, that is how it is. So it is a sign table. You know how to read tables. Okay, then the last row, you have your product. This is x minus 2, 3x plus 1. Here, my factors are multiplying, so I should also multiply their signs. I have negative and negative. When I multiply them, I get positive. I have negative and positive. This gives me negative. Positive and positive. This gives me a positive. Then I write the question again after I had factorized it. So I have x minus 2, 3x plus 1. This is less than or equal to 0. Now this less than or equal to 0 is what I will use to decide which regions I am looking for. Less than or equal to 0, this is negative. So this is negative. So I go to my table. In the last row, the column that gives me negative, so that's that one over there. And that means the numbers between -1/3 and 2. So here, my solution, I will put this in square bracket because of the equal to under there. And then I have -1/3 to 2. Or I could represent this on a number line, -1/3 to 2. My circle is shaded. This is shaded. And then I connect them like that. So that is how you would solve any quadratic inequality. The first thing is always make sure that you take everything to one side, 0 on the other side. So if it is then you factorize. If it is not if it is factorized, then you skip that step. You find your critical points. The critical points divide your number line into 3 regions. Pick a representative in each of those regions. Substitute them into the factors. Multiply the signs of the factors, and then see what you get depending on what the question is asking you to do. So it's pretty simple. You can write down step 1, step 2, step 3, step 4. And then for any question, just say, okay, step 1 tells me to do this, do it. Step 2 tells me to do this, and then go ahead and do that. All right. Then the last thing we look at is logarithmic inequalities. Okay. Inequalities. Okay, so just like the name suggests, these are inequalities that involve logarithms. Now what we know about a logarithm, that if we are given this log the base a of b, this logarithm is not defined for any values of a and b. So it means that there are some values for a and b where you will get a math error. It is not defined. Now the first thing is that our base over here must be positive. So a must be greater than 0. And we also know that a is not equal to 1. So if the base of the logarithm is 1, then your logarithm will not be defined. And then this is a restriction on the base. And then for the argument b over here, we know that b must be greater than 0. So your argument must always be a positive number. If your argument over here is negative, you can try that. Log of anything, log any base but your argument is negative, you will get a math error. So you're not allowed to take the log of a negative number. So this is one thing that we must always ensure is kept. Our argument must always be greater than 0. It must be positive. Now with logarithmic inequalities, I will give you something like this. Log base A of B is, let's say, less than C. Can be less than or equal to, greater than or equal to. The inequality itself doesn't matter. Now there are two ways to solve this, okay, depending on what your value of A is. Now if A is less than 1, if A is less than 1, what you will do is you will raise both sides, or both sides will have a base of A, and then the exponents. Let's look at an example. What you will do is this. You will have A log base A of B, and then your inequality will change the direction that it is facing. It will now face this way, and then you will have A to the power of C. So you'll exponentiate both sides. So this will become the exponent of A, that will become the exponent of A, but then your inequality will change the direction that it is facing in. This is when A is between 0 and 1. For example, if A is equal to a half, then your inequality changes direction. And then we know that if I have a base A of my exponent and a base A of my logarithm, this from your laws of logarithms is just equal to B. So I will have B is greater than A to the power of C. And you know how to solve these ones. Then if your A is greater than 1, let's say A is 5, for example, and then you are given log base A of B, this is less than C. Here you just exponentiate both sides. The sign remains the way it is facing. Okay, so you can see over here it was less than. When I make each of the sides an exponent, the sign is still facing the same direction, and that is because A is greater than 1. Now let's look at an example. So keep that in mind when you have a number or your base is less than 1, switch the sign. It must face in the opposite way. If it's greater than 1, do not switch the direction that it is facing in. So if we look at the first one, we have log base 3 of x. This is less than minus 2. So what I will do is I will say 3 to the power of the left hand side. This is less than, the sign does not change. Why? Because my base is greater than 1. And then I have 3 to the power of the other side. Okay, then here this is 3. The base of the logarithm over there is 3. This is equal to 3. This is equal to x, sorry, from your laws of exponents. And then this is less than 3 to the power of minus 2. Now we know that 3 to the power of minus 2, this is 1 over 9. So this is the first part of your solution. Now when I give you this question, log base 3x, this must be defined. Okay, so in order for this to be defined, this argument over here, x should be greater than 0. Okay, so if x is greater than 0, then it will be defined. But because I also want my logarithm to be less than negative 2 over here, both of these conditions must be met. So what I do is I draw my number line, and I will put both conditions on the number line. And because I'm saying both conditions must be met, when I look up where I'm standing on the number line, I must see 2 lines. If I see only 1 line, that is not enough. So here I will put 0, and then I have 1 over 9 there. So the first condition, it says that x should be less than 1 over 9. So the circle is open because it's strictly less than, and then I go to the left. Then the second condition says x should be greater than 0. So my circle is open because it's strictly greater than, and then greater than 0, I go to the right. Then I look up. When I walk on my number line, what is the region where when I look up, I see 2 lines above me? That is in this region over here. Okay, so I can redraw it. This is 0. This is 1 over 9. My circles are open, and there is my solution. And then I can also write it in interval notation. This is from 0 to 1 over 9. And you can always check. First, try picking a number over here. Substitute it on your calculator. You will see you get a math error. And then try substituting a value of x in that region. Let's say 5, for example. You will see that your answer is not less than -2. So the only solutions you get will come from numbers in that region. Then we look at another example. We have log base 1 over 4 x. This is less than 4. Okay, so this is one where our base is less than 1. Remember, the procedure is the same. I will still have a base of the exponent equal to 1 over 4, and then I'll raise it to log 1 over 4x, and then on the other side I will also have 1 over 4 to the power of 4. And now my sign will change the direction that it is facing in. It was less than, then it becomes greater than. The reason it changes direction is because this number over here, the base of my logarithm, is less than 1. So when your base of the logarithm is between 0 and 1, when you exponentiate both sides, it should change direction. So here, this will be x, because the laws of the logarithm say if you have base of the exponent equal to base of your logarithm, then this is just equal to the argument that you have over there. And this is greater than 1 over 4 to the power of 4. This is just 1 over 256. Okay, so this is the first condition. And then we always have to keep in mind that our argument over here must always be greater than 0. Otherwise, the logarithm is not defined. So you have to make sure the logarithm is defined, and then it also satisfies this condition that we have worked out. Then you combine those two, and because we're saying the logarithm must be defined and it must satisfy, so what we have is this first one, and the argument x should be greater than 0. So I'm using and over here. And means when I look up on my number line, I should see 2 lines above me. So what you do is you draw your number line, you put the 2 numbers, you have 0, and then you have 1 over 256. The first condition says x should be greater than 1 over 256. So you put open circle because it is strictly greater than, and then greater than means you go to the right. Then the second condition for the logarithm itself to be defined, you say greater than 0. So at 0, my circle is open because it is strictly greater than, and greater than means you go to the right. Then you ask yourself, where on this number line should I stand so that when I look up, I see 2 lines above me? That is in this region over there. Then you can draw your final solution. So here I have 1 over 256. My circle is open, going that way. And then in interval notation, this is 1 over 256 to infinity. Then number 3, we have log base half of x plus 1. This is less than log base half of x plus 8 minus log base half of x minus 4. Okay, now this one is a little bit different, but we have to apply the same principle in that I need to compare only 2 logarithms. I should have one on either side. So on the right hand side I have 2 logarithms, so I need to combine them. I cannot have 2 logarithms. So the left hand side will remain as it is, so this is log base half of x plus 1, and then on the right hand side, because I'm subtracting and the bases are the same, that means I will divide the arguments. So this is less than log base half, this is x plus 8 over x minus 4. So that is how we work out the laws of logarithms. Then I would do the exact same thing. I would raise both sides to the power of a half, or I'll make half to the power of both sides. So I have half to the power of log base half of x plus 1, and then my sign will change direction. Why does it change direction? Because the base is less than 1. So this becomes greater than. Here I have half log base half, then my argument, this is x plus 8 over x minus 4, like that. And now here the base of the exponent and the base of the logarithm are the same, so the answer is just equal to the argument. So I have x plus 1, this is greater than, and same thing on the right, the base of the exponent and the base of the logarithm are the same. So what I have left is the argument. Okay, so now here what I will do is I will multiply both sides by x minus 4. Now we know that when we multiply by any number on both sides of the inequality may or may not change direction. Now in this case, we don't know what x is, but I know that x minus 4 is positive. Now the reason I know that it is positive, here I need to backtrack a little bit. Let's go to the question. Now if you look at my question over here, this x plus 1 is an argument. Because it is an argument, it must be greater than 0. This x plus 8 is an argument. Because it is an argument, it must be greater than 0. Otherwise, the logarithm is not defined. Same thing over here. This x minus 4 is an argument, which means that it must be greater than 0. So over here, when I multiply both sides by x minus 4, I know that x minus 4 is positive. There's no way that it is negative, because if it is negative, then my logarithm is not defined. If you do not know for sure that x minus 4 is positive, you cannot multiply both sides, because you then do not know if your inequality should or should not change direction. But in this case, I know that x minus 4 is positive. That's why I can multiply and know that the sign does not change direction. So here I have x plus 1. This is x minus 4. This is greater than x plus 8. So here you can see you'll end up with a quadratic inequality that you should solve. You multiply out the brackets, so you'll have x squared minus 4x. So remember how we do it, like that. Then plus x minus 4. This is greater than x plus 8. And then x squared, collect everything on one side, 0 on the other side. Okay, so that is what you have. You subtract x on both sides, then this x will be gone. You subtract 8 on both sides, that's where I get the minus 12 from. Then from a logarithmic inequality, we end up with a quadratic inequality. We know how to solve that one. We need to factorize. So you look for two numbers. When you multiply them, the answer is negative 12, and when you add them, the answer is negative 4. So that is negative 6 and positive 2. Then from here, what you do, you find your critical points. So you can see with these questions, nothing is in isolation. So doing logarithmic inequalities, you should still know how to work out quadratic inequalities. So everything is interlinked. So you have x minus 6 is equal to 0. This means that x is equal to 6. And here x plus 2 is equal to 0. This means that x is equal to minus 2. Then draw your sign table. You put your values. I have 6 over there. I have minus 2 over there. Then you extend your table to, you extend the sign number line to form a sign table. Then you have x minus 6. And then you have x plus 2. Then you close. Then you pick a representative, a number less than negative 2, let's say negative 3, a number between negative 2 and 6, let's say 0, a number greater than 6, let's say 10. And then you substitute each of these numbers into the factors, negative 3 minus 6, negative 3 plus 2, negative 0 minus 6, negative 0 plus 2, positive 10 minus 6, positive, and then 10 plus 2, positive. And then the product of the factors. So you have negative and negative. This gives you positive, negative and positive, negative, positive and positive. This gives you positive. Then you write down the original question that you were looking at. You said x minus 6 multiplied by x plus 2. This should be greater than 0. So you look at the last row. Greater than 0 is that first column and that last column. So you can write this as minus infinity to negative 2 union 6 to infinity. So this is the first condition. So remember when we were solving the other logarithmic inequalities, we had the first condition and then we had to include the conditions of the arguments and then look above where we see 2 lines. Now here I have 3 arguments. That means I will have 3 conditions for my arguments that I need to combine with this one over here. So the first argument was x plus 1. So I have to say x plus 1 should be greater than 0. So that's this one over here. So this one in blue over here, that's what I'm writing now. So I combine all 3 of them. So x plus 1 is greater than 0. This means x is greater than negative 1. So this is the second condition. Then the third one, we had x plus 8 is greater than 0. This means that x is greater than negative 8. Third condition. Then the last one was x minus 4 is greater than 0. This means that x is greater than 4. So I will draw a number line with all 4 of these. This is the first one, the second one, the third one, and the fourth one. And then I look above on my number line. Where do I see 4 lines? Okay, so let's do that. So I have my number line. So the very first solution that I got from the quadratic inequalities was from negative 2 going that way, and then 6 to infinity. This is the first one. Then I got x should be greater than -1. -1 is somewhere here. So my circle is open. I'm going in that direction. The second one was that x should be greater than -8. -8 is over here. My circle is open. I'm going in that direction. Then the last one was x should be greater than 4. 4 is here. So put my open circle, then going that way. Then I look for the region on my number line where when I stand there, I see 4 lines above me. So that is this going that way. So this region over there, when I look up, I will see 4 lines above me. So the final solution will look like this on the number line. So from 6, the circle is open because that circle is open there at 6, going that way. Or in interval notation, what I have is from 6 to infinity. And that's it. So the more arguments you have, the more restrictions you have, and you need to make sure that each of them is satisfied.
Miss,
Okay, yes.
what happened to the fifth line, the one that starts from -2 going to the
You mean this one over
left?
here? Is that the one you mean?
Yes. Yes.
Are you saying why am I not including it?
Yes, ma'am.
I said I need to find a place on the number line where I stand, and when I look up, I must see 4 lines. If I stand over here, there's only these 2 lines above me. That's not what I want. So when I stand in this region, I see the first line, the second one, the third one, and the fourth line. That means all 4 conditions are met. Over here, only this condition is met, this side. That's not what I want. Then the logarithms will not be defined. So it must fit into the solution that I got here, the one with the star, and the logarithms must also be defined. That's why the solution is only from that to that.
Okay, thank you, ma'am.
Okay. Do you have any other questions? Okay, so with logarithms, the tricky part is just remembering that your logarithm must be defined. That is important. And when the logarithm is defined, that means you're adding an extra condition that must also be met. So with this one, we had 4 conditions that we had to meet. So it means that I must see 4 lines above me. Okay, so I set a tutorial worksheet. It's in the tutorial folder. Please go and try it. You'll see that most of the questions in the tutorial tests are similar to the questions in the tutorial worksheet. So please go and try that. Do the tutorial tests. This week it closes on Sunday as usual because we don't have any practice test to submit. So yeah, that's it. So again, please, if you have any queries, call me on Teams, not on my phone, on Teams. Send me an email or an e-learning, not on WhatsApp, please. Okay, so have a good day. Tomorrow we will start on another topic.